Bismillahirrahmanirrahim. Assalamu alaikum. Hello, students. Welcome to the Electrical Engineering channel. In this lecture, I am going to discuss the divergence theorem. In the previous lecture, we actually studied that the Maxwell's first equation is the divergence of D equal to volume charge density, and the Maxwell's first equation in integral form is D dot ds is equal to Q. So Q is equal to D dot ds, and its closed surface integral, right? This is the Gauss's law, and we also know that Q is equal to rho v dv. Okay, or we can say that Q is equal to rho v dv volume integral, and rho v is equal to del dot d. This is also the Maxwell's first equation in point form. The divergence of D is also equal to rho v. So rho v can be replaced with the divergence of D. Okay, and this is the volume integral. So by comparing these two equations, we can write d dot ds closed surface integral is equal to del dot d dv volume integral. So this is called divergence theorem. So this is a divergence theorem, and it is actually the transformation of a surface integral to a volume integral. Here we have a surface integral or a closed surface integral. Here we have a volume integral. And del is the vector operator, and in this theorem we only see only one vector quantity, which is d. So this divergence theorem is applied on the vector field d, but it can also be applied to any arbitrary vector field a, b, or c, or any arbitrary vector field can be applied, and this is called the mathematical form of the divergence theorem. So that is all about our today's lecture. For watching more lectures, please subscribe this channel. Until the next lecture, it's goodbye.